In this video, we're going to practice with determining the composition of two functions, also called composing two functions, and then finding the domain of that composition. So our first example here is simply a composition of two polynomial functions, f of g of x. So the first thing I'm going to do, I want to determine f of g of x. I'm going to write the definition of this function, which is f of g of x, and I always put my g of x smaller inside. And then I work from the inside out. So g of x is what goes on the inside, so I'm just going to copy down the shell of everything else, and I'm going to replace g of x with what it is. G of x is 2x plus 1. It literally tells us over here that g of x equals 2x plus 1. And now what I'm going to do is take my 2x plus 1, it's inside parentheses, so this is an input to the f function. So that means I'm going to go to my f formula, and everywhere there's an x, I'm going to replace with this input, 2x plus 1. So it's basically going to look like something squared plus 2 times something, right? That's what the f function is. It squares your input and then multiplies it by 2 and adds. The input, though, is my 2x plus 1. And then I simplify this. So 2x plus 1 quantity squared means take 2x plus 1 times itself, and you're going to get 4x squared plus 4x plus 1. That's what this turns out to be. Plus, and then I'll distribute my 2 to get 4x plus 2. And when I combine my like terms, I get 4x squared plus 8x plus 3. So f of g of x has this formula for its output. Now the second part that I'm going to do here is find the domain of this new function. So when I want to find my domain, I have to look at my function before I simplify. So this step here, before I distribute or anything, I'm going to find my domain before simplifying. So I look for things like denominators and square roots. There are no denominators or square roots or any calculations that present us any troubles here. So that means my domain is all real numbers, negative infinity to infinity, the entire number line. So that one is pretty simple as far as the domain goes. Let's look at a more complex example. So now in this new example, we want to determine g of f of x. So watch that order as you work through this, where f and g are two rational functions. They're fractions. So we're going to start with g of f of x, write the definition, which is g of f of x, and we'll work from the inside out. So I'll look for f of x, and I'll copy my g of portion down, and I'll replace just the f of x with its definition, which is x over x plus 2. Now I'm going to take my x over x plus 2, that fraction, as the input to the g function. So inputs go in place of x in the g function, so I'm going to take 2 over my new input, x over x plus 2. Notice that I've got a bigger fraction bar here because it's 2 over my input, and my input is the red fraction, so it's 2 over the fraction as opposed to 2 over x plus 2. Those are not the same thing. Okay, so the size of that fraction bar really is useful here. So now I need to simplify this, and if I'm going to take 2 divided by a fraction, that's the same thing as 2 times the reciprocal of that fraction. And then I need to multiply these together. So 2, I could think of as a fraction being 2 over 1, And so if I multiply the top, I get 2x plus 4. If I multiply on bottom, I get x. So that's my simplified output for the g of f of x function. This is the formula for my g of f of x function. Let's look at its domain. For domain, I look at my unsimplified version, which is this guy right here. Now, I don't have any square roots, but I have multiple denominators. For example, x plus 2 is a denominator. I need that to not be 0. So I know that x can't be negative 2, because if I were to plug negative 2 in for x, that denominator would equal 0. But also, the entire fraction is a denominator of the big, this entire red fraction is a denominator of the bigger complex fraction. So I can't have that equal 0 either. So a fraction equals 0 if the numerator equals 0. So I know that x can't be 0. Check it out for yourself. If you plug 0 in for x, you'll see that you'll end up with 2 divided by 0. And you can't take 2 divided by 0. So my domain is every x value but those 2. If I look at that on a number line, it looks like everything but those 2 numbers. And an interval notation is negative infinity to negative 2, union negative 2 to 0, union 0 to infinity. So this is a more interesting example. The problem with composition or combining functions of any kind is, do you know how to work with the 2 original functions? For example, here we had rational functions and complex fractions, and so your basic algebra skills are really important here. The purpose of this video is not to teach you about fractions, it's to show you the idea of composition. And so the first example we did was with polynomials, same concept as the second example we did with rational functions. The basic algebra skills are kind of what dominate the work in these problems though. So I hope that all makes sense, especially the domain portion, which can be tricky.